Hi, Professor. I'm Naveen Srikakulam. For this Grad 695 project, I'm analyzing Spotify audio features to understand what drives song popularity over time. At a high level, the project starts from a simple question. Spotify logs a lot of technical features for every track, but which of those really seem to be connected to popularity and mood? I focus on two outcomes, the platform's popularity score and valence, which captures how positive or happy the track sounds. I look at these relationships both at an individual level and at an aggregate level to uncover some patterns and insights. This slide lays out the main research question. First, amongst all the Spotify audio features, which ones are the most strongly associated with a track's popularity score? Second, how do audio features relate to valence, the emotional tone of the music? And I'll also do feature outcome relationships. Uh, I want to see if they stay stable across decades or they shift as the listening preferences evolve. In this slide, I'm explaining why this topic is interesting. I think for creators and labels, knowing which musical traits help higher popularity can inform some business decisions about production, promotion, positioning, etc. For product and recommendation teams, it's a nice test case of building models on public audio features. And because the data span almost a century, we can also say something about how musical mood has changed over time. On this slide, I briefly describe the data. I'm using Kaggle's Spotify dataset that combines several CSV files. Um, the years are 1921 to 2020. The two main outcomes are popularity on a scale of 0 to 100 and valence, which measures how positive a track sounds. And predictors include danceability, energy, etc., that you can see in the slide here. For this analysis, I first do basic exploration, look at distributions, check data quality, and see simple correlations between features, popularity, and valence. Then I build models. For popularity, um, I will use multiple linear regression as a baseline and then ridge or lasso to handle multicollinearity and highlight key features. For Valence, I use the same setup and may test a few simple feature interactions. Before any modeling, there is an important cleaning step. I start by loading all the CSV files and check for duplicate tracks using Spotify track ID and name. After removing duplicates, I will standardize data types and confirm that variables are in expected ranges. For any missing data, if the percentage is small, I'll drop those rows. If it is moderate, I will use simple imputation and compare results. And if I'll also flag any outliers in um, loudness, tempo, duration, etc., and test models both with and without these extreme values. And coming to limitations, there are a few. Popularity is a Spotify specific metric driven by their algorithms and users. So it may not be, so we cannot generalize this to other platforms. I also don't have user level behavior like skips or saves or replays, etc. And genre labels can be messy, and there is survivorship bias because only certain tracks are on Spotify. Finally, this is all correlational, so factors like marketing and artist fame may still be driving the results. And the final slide to wrap up this summarizes what I expect to deliver. I'll have a set of regression and regularized models that show how much variation in popularity and valence can be explained by different audio features and time. I'll also produce clear feature importance views and visualizations. Alongside that, I'll write a short non technical summary that translates the results into plain language. All deliverables will be documented thoroughly for my final capstone project next semester. Thank you.